So what happens? We start with an unstretched rubber band. We do some work on the rubber band to stretch it. We have to exert a force through a distance. So we start with the unstretched rubber band and we stretch it out. Should have made the stretched rubber band a little skinnier, but we can make it fat. Just stretch it between 2 fingers instead of 1. Okay, so we get a stretched rubber band. We put some work into this rubber band. Where does that work go? Well, the work that we put in goes into 2 things. Potential energy, as we've seen, and thermal energy, which we haven't talked about to this point. Now let me explain. You need to experience this yourself. Get a good clean rubber band. Take one of the rubber bands that came in your kit and put it in boiling water for a few minutes, and if it doesn't ruin the rubber band, now you'll have a sterile rubber band. Or sterilize it with some kind of a bleach solution, whatever it takes to sterilize it. Don't put a dirty rubber band on your upper lip, because this is what you're going to do. You're going to put this rubber band against your upper lip. Let's say your lip's right here. You're going to put this strand, I've got to get my hands out of the way, this strand right against your lip. And you're going to stretch it very hard, very fast. You'll feel definite warmth. It won't burn your lip, it won't harm you, but you'll definitely feel warmth. Also, when you take the rubber band and suddenly let it decompress still against your lip, it's going to feel cold. I can even feel that in my hand here. Okay, the rubber band stretched out feels warm. When it comes back, it feels cold. But you can especially feel that against your upper lip. So I'm not talking about putting it in your mouth, but up against your upper lip. Just under your nose there. It's very sensitive to heat. Okay, so there is thermal energy involved when you stretch a rubber band. Some of this thermal energy dissipates. Before you let the rubber band unstretch, before you let it snap back, some of that thermal energy escapes into the room. There's an exchange of thermal energy between the rubber band and the air around it. The air around it is cooler than the rubber band, so that the rubber band loses thermal energy. Now, when the rubber band snaps back, whether it's snapping back on its own, you just snap back like this, ouch, okay, or snapping back to propel that rail forward, you get the potential energy and the thermal energy of the rubber band convert into kinetic energy. The kinetic energy of the rail or the kinetic energy of the rubber band itself. Okay? So we put work into the rubber band and it goes into potential energy and thermal energy. If we put so many Newton centimeters of work in, most of those will go into potential energy, but a significant number of your Newton centimeters will go into thermal energy. When the rubber band snaps back, whatever excess thermal energy you have that hasn't been lost to the room is going to be regained. Well, I'm not going to get into that, but the thermal energy of the rubber band, even if it's at room temperature, some of that thermal energy will be converted into kinetic energy. So the potential energy and some thermal energy gets converted into kinetic, giving you a velocity. It's a very important idea. You put energy in, you get it in this form, and then you get most of it back except what's been dissipated due to the temperature exchange or the thermal energy exchange with the room.